In this lesson we are going to look at transformations, and this will cover activities 3, 4, and 5 in the quadratic unit. So a transformation is any change in the size, shape, position, orientation of a function. So if a function or shape has undergone a transformation, we say it has been transformed. We call the original function, sometimes we call it the parent function, you'll see that quite often, or the object, and then the transform function is the image. So there's three main types of transformations: there's translations, dilatations, and reflections. Translations are really just another word for shift. We can shift both vertically or horizontally. Dilatations are like your eye dilating, your iris or your pupils. When they dilate, they either stretch or compress, and they can do that both vertically and horizontally. And then reflections are mirror images in the x and y axis, so both vertically and horizontally. So we're going to look at each of these. So we're going to apply these transformations to the graph root x. So what does root x look like? So if you're not sure what a function looks like, we can use a table of values. Now remember that we can't square root a negative number. So we're going to start our table of values with 0. So the square root of 0 is 0. The square root of 1 is 1. I'm going to skip over to 4. If I square root 2 or 3, I'm going to get a decimal, so I'm going to skip to 4. Remember, you can use whatever x you want. Square root of 4 is 2, and then I'm going to skip over to 9 because I know the square root of 9 is 3. So this is my basic square root graph. Now, when you square root a number, we have talked about that you could have a negative value as well. So when I square root 1, I could have 1 or negative 1. When I square root 4, I could have 2 or negative 2. And when I square root 9, I could have 3 or negative 3. And so let's have a look at this. So the function starts here at 0. It's 1, 1, 4, 2, and 9, 3. We could also have 1, negative 1, 4, negative 2, or 9, negative 3. And so when we talk about plus or minus root x, this would be the positive answer of root x, this would be the negative answer of root x. So when we say plus minus, you'll see both arms. Sometimes it will just specify the positive and you'll only see the top, or sometimes we'll have the top and the bottom. So if you were typing this into Desmos or on a graphing calculator, you would have to type in positive root x and negative root x as separate equations, because it probably will only show you the positive. So here we're going to, on the same set of axes, graph the following, and we're going to do the positive answer because I just want to show the transformations. I'm not really worried about both sides. So I'm going to do positive root x so we'll start with that. So here's root x. If I went to graph root x plus 3, I'm going to take each of these answers for y and I'm going to add 3. So what does that look like? So the square root of 0 is 0, plus 3 is 3. The square root of 1 is 1, plus 3 is 4. The square root of 4 is 2. 2 plus 3 is 5. So it's going to go over 4 and up 5. And so the graph looks like this. So root x plus 3, it has the same shape, but it has shifted the graph up 3 units. Root x minus 2, we're going to do the same thing. We're going to square root x, and then after we've square rooted, we're going to subtract 2. So square root of 0 is 0 minus 2 is negative 2. Square root of 1 is 1 minus 2 is negative 1. Square root of 4 is 2 minus 2 is 0. So that's going to look like this. So we square rooted x, and then we subtracted 2 after, and that shifted the graph down at each individual point 2. I think we need the negative. So a value that is added after the function shifts vertically. So it shifts the graph vertically. So sometimes we say f of x and we call that b. So that transformation is a vertical shift if you add after the function. So if it's positive, it's going to go up. If it's negative, it's going to go down. So what if we did the next two? So we're going to start with root x. 1, 2, 3, 4. So we're going to start with root x. So we'll draw the parent function. So there's root x. And then we're going to, before we square root, we're going to subtract 3. So I can't use 0 because 0 minus 3 gives me a negative number. So the number I can use that is the smallest number would have to be 3, because 3 minus 3 gives me 0. So when x is 3, so 3 minus 3 is 0, square root of 0 is 0. When x is 4, 4 minus 0 is 1, square root of 1 is 1. So 4 gives me 1. And then I'm going to skip over to 7, because 7 minus 3 is 4, and the square root of 4 is 2. So 1, 2, 3, 4, 5, 6, 7, 2. So what has that done to the graph? This is root x minus 3, where the 3 is inside the square root. So we're shifting it 3 to the right first, and then square rooting. So what if we did root x plus 2? So how do I get a 0? Well, negative 2 plus 2 is 0. So if I go negative 2, x is negative 2, I get 0, square root of 0 is 0. If I get negative 1, negative 1 plus 2 is 1, square root of 1 is 1. And then if I get, let's see, what's going to give me 4? 2. So 2 plus 2 is 4, square root of 4 is 2. So this is root x plus 2. So root x plus 2 shifted the graph left 2, and root x minus 3 shifted the graph right 3. So if the number was added or subtracted after the square root, it moved it up and down. If the number was added or subtracted before the square root, it shifted left and right. And sometimes we say this is f of x minus d. We use the letter d. So this is a shift left and right. F of x plus b is a shift up and down. Okay, let's see what happens when we multiply by a number. So we're going to do the same thing. We're going to do root x as the parent function. We've got 0, 1, 4, 2, 9, 3. There's root x. Now I'm going to multiply by 2 after I square root. So square root of 0 is 0 times 2 is 0. The square root of 1 is 1 times 2 is 2. The square root of 4 is 2 times 2 is 4. So before 4. So the graph has not shifted, it has been stretched. So it's twice as high as it was. If I do a half, square root of 0 is 0, times a half is 0. Square root of 1 is 1 times a half is a half. Square root of 4 is 2. 2 times a half is 1. And so this is 1/2 root x. So this, we'll say this is compressed because it's squished down. So it's really important with stretches and compressions to know where that number is. Is it inside or outside? Because think about if I look at the top one, I can say it's vertically stretched. I could also say it's horizontally compressed. They will do the same thing. So pulling something up also squishes it in. Okay, so let's look at these. Let's switch to a parabola and see how that affects it. So we're going to multiply. Some of them are inside the brackets, some of them are outside the brackets. Okay, so x squared. 0 squared is 0, 1 squared is 1, 2 squared is 4. Negative 1 squared is also 1, negative 2 squared is also 4. So it is symmetrical. Get the same value on both sides, so this is x squared. Let's do 3x squared first. I'm just going to tidy this up a bit. A little bit messy. Okay, so let's do 3x squared. So I'm going to square 0, multiplied by 3 is 0. I'm going to square 1, so 1 squared is 1 times 3 is 3. Negative 1 squared is 1 times 3 is 3. So what does that do? Well, we could say that stretches it vertically by a factor of 3. What if we did 3x first and then squared it? I'm just going to do this in a table here. So 0, negative 1, negative 2, 1, 2. So we're going to do y equals 3x, and then we're going to square it. So 3 times 0 is 0, squared is 0. 3 times 1 is 3, squared is 9. 3 times negative 1 is negative 3, squared is also 9. Let's do this in green. So we've got 0, 0, we've got negative 1, 9, we've got positive 1, 9. The problem with stretches and compressions is, as I said before, vertically stretching looks like a horizontal compression. So a vertical stretch also equals a horizontal compression. So if you think of a shape that's stretched this way, right? If it stretches this way, it's also compressing it this way. If I had a circle and I pulled it up and down, I would be also squishing it in. Also, a vertical compression equals a horizontal stretch. They look the same. So again, think of a circle. If I take a circle and I vertically compress it, right? I squish it down. So I vertically compressed it. I've also horizontally stretched it. So horizontal stretches and compressions look the same as vertical. So it's really important that you know where the number is, whether it's inside the function or outside the function. Because y equals 2x squared and y equals 2x squared are two different things. This is a vertical stretch because it's after the function. I'm squaring first and then I'm multiplying by 2. It's considered outside the function. This is considered inside the function because the 2 is multiplied first and then squared. So this would be considered a horizontal transformation, and it would compress it. Okay, we'll look at all this in a summary in a minute. And then what about reflections? So root x, put this on the graph, 1, 2, 3, 4. 1, 2, 1. So square root of 0, square root of 1, square root of 4. That's root x. So what does negative root x do? Well, negative root x applies the negative after it's outside the square root. So square root of 0 is 0, negative 0 is 0. Square root of 1 is 1 and then negative. So x is 1, y is negative 1. Square root of 4 is 2, x, and then we have the negative. So square root of 4 is 2, and then it would be a negative applied, so it would be negative 2. So this is negative root x. So the x's are staying the same, and the y's are going to become negative because you're applying the negative to the answer. So this is a vertical reflection, and since the x-axis is the mirror line, we say in the x-axis. If we do the negative first, we get a different result. So 0, 0, that's going to be 0. If I say x is 1, now I have negative 1. Well, I can't do that because I can't square root a negative. So how am I going to make that a positive number? I'll have to use negative values for x. So let's say x was negative 1. A negative times a negative is a positive. Square root of 1 is 1. So when I use x as negative 1, I get y as 1. If I use square root, if I take x as negative 4 and apply this negative, now I have positive 4, which gives me an answer of 2. So this is negative root x. So this is a horizontal reflection in the y-axis because the y-axis is now the mirror line. So this is a summary of our transformations, and there's a few rules you have to think about. Anything outside the function, so done after, is always a vertical transformation. So any number that is outside the brackets is always a vertical. Any number that is, let's use a different color. Any number that's inside the brackets is a horizontal transformation because you do it first and therefore it affects the x coordinate. So outside the brackets is vertical, inside the brackets is horizontal. Anything added is a shift, so added or subtracted. So this would be a shift. Anything multiplied is a stretch or compression. And then finally we have our reflections. Inside is a horizontal compression, outside is a vertical compression. And then the last thing to remember is x transformations, the opposite. What do I mean by that? Well, I mean that it will do the opposite. So if I had x minus d, it's going to go left, or sorry, right. Because we already have a negative, so the 2 is the transformation, so that's going to go right. If I had x plus 2, it's going to go left, because now I have x minus a negative, so that's going to go left. So this is my mapping notation. My mapping notation describes how each coordinate is going to be affected by the transformations. So often you will ask to provide mapping notation. So x's, the numbers inside the bracket affect the x. So the d and the c, right? These two numbers are inside, so they're going to change the x coordinate. And when they're going to do the opposite, so c will be 1 over c and minus d will be plus d. The a and the b are outside the bracket, so they're going to change the y coordinate. And they do exactly what they say. So let's look at a couple of examples. Once we do a few, it gets much easier. Okay, describe the transformation, provide the mapping notation, and sketch a graph. Okay, so I'm going to go from left to right. So the 2 is outside the brackets, which makes it horizontal. It is multiplied, so it's a stretch. And then we always say by how much. So say factor 2. The next number is the 1. The 1 is inside the function being root x. So I'll say, oops, let's erase this and start over. Did that backwards. Okay, the 2 is outside the brackets, which makes it vertical. The 1 is inside the brackets, which makes it horizontal. It is subtract 1, so it's going to shift and it's going to go to the right. And then the 5 is outside the bracket, so it's vertical. It's added, so it's a shift. And then it's positive, so it's going to go up. Okay, the mapping notation explains what's going to happen to the x. So the number inside the square root is going to change the x. It's going to be the opposite. So it says x minus 1, so the result will be x plus 1. The 2 and the 5 are outside the function, so think of the function as root x, and they're just going to do exactly what they say. They're going to multiply by 2 and they're going to add 5. So here's my parent function. So there's root x. That's what we're starting with. So I can pick some numbers. So 0 zeros on root x, 1 ones on root x, and 4 2. What's going to happen to those points? Well, the x is going to add 1. So 0 plus 1 is 1. 1 plus 1 is 2, and 4 plus 1 is 5. What's going to happen to the y? Well, we're going to multiply by 2 and add 5. So 2 times 0 is 0, plus 5 is 5. 2 times 1 is 1, plus 5 is 7. And 2 times 2 is 4, plus 5 is 9. These are my new points. Let's see if we can fit these on here. So 4, 5, and then it's going to go all the way up here. So I'm just going to estimate where these are. So 1, 5 would be approximately here. 2, 7 would be up here. And then 5, 9 would probably be somewhere up there. So this point is 1, 5, this point is 2, 7, this point is 5, 9. And that is my transformed image. Okay, in this question we have a parent function of x squared. So what does the half do? It's outside the bracket, so it is a vertical, it's a half, so we're going to say it compresses because it gets smaller. And then we say by how much. The 1 is inside the bracket, so it's horizontal. It's added, it's added, so it's a shift, and it's plus 1, so it's going to go left 1. And then the 3 is outside the bracket, so it's vertical. It's subtracted, so it's going to be a shift. It's negative, so it's going to go down. My mapping notation. What's inside the bracket? Plus 1, so it'll be x minus 1. What's outside the bracket? The half, and then the minus 3. So I'm going to sketch my graph here. Just plot a few points. So 0, 0, 1, 1, 2, 4. Same on the other side. Will give me my parent function, which is x squared. So I used 0, 0, 1, 1, 2, 4. I also used negative 1, 1, and negative 2, 4. So these are the numbers I used on my original graph. So the x, I'm going to subtract 1. So 0 minus 1 is minus 1. 1 minus 1 is 0. 2 minus 1 is 1. Negative 1 minus 1 is negative 2. And negative 2 minus 1 is negative 3. So these are my new x values. My y values, I'm going to multiply by a half and subtract 3. So 1 half times 0 is 0 minus 3. A half times 1 is a half, minus 3 is negative 2.5, or 5 over 2. A half of 4 is 2, minus 3 is negative 1. A half of 1 is a half, minus 3, negative 5 over 2. And then a half of 4 is 2, minus 3 is negative 1. So I'm going to plot these on here. Put some points here. So negative 1, negative 3, 0, 2.5, 1, negative 1. Then we've got negative 2, negative 2.5. Then we've got negative 3 and negative 1. Oops. So it's going to look something like this. So it's been shifted left 1, down 3. I can tell that because that's that point there. So this point here has gone left 1, down 3, which corresponds to this point. And it's also being compressed by a half. Okay, so there's some practice questions here. So in the question 1, you're going to write the transformations in words and mapping notation. And then in question 2, you're going to use root x as the parent function, and then you can apply these transformations and draw a picture. You can check on Desmos to see if you're correct for this one. So for example, this equation would be 2 root x. This equation would be root 2x. This equation would be x plus 2 square root. This equation would be root x and then minus 2. This would be minus root x, and this would be 1/2 x and square roots. The ones you'd have to be careful of is something like this. So horizontally, the stretch and compression have to be separate. So if they're not, you have to factor. So I'm going to factor out the 1/3, the coefficient. So 2 divided by 1/3 is 6. And just to check, 1/3 of 6 is 2. So you can reverse it just to make sure you're correct. So 1/3 of 6 is 2. So what I've done is factor, and that is going to separate the horizontal stretch from the shift. Okay, they have to be separate, so it's not factored, you have to factor it. The same with this one needs to be factored. Okay, and this one. So these last 3 need to be factored. So factor out the coefficient so that you separate the stretch from the shift. Other than that, I didn't provide the mapping notation, but I did do the transformations in words, and then type question 2, you can just put into Desmos the equation just to make sure that your graph looks correct.